there are 16 students in class, the number of ways in which 4 students can be chosen to complete a survey. It says survey, but it should say survey. Or survey, whatever. Is the survey any different for any of them? No. So we would have 16C4. And if we fill that into our formula on our formula sheet, the formula on our formula sheet is n factorial over n minus r factorial. Now you could punch this technically in your calculator, and you could type all 4 of those in your calculator and match the answer, right? If you have no idea how to do the question. But the proper way would be to actually fill it in the formula. This would be our n, this would be our r. So we're going to get 16 factorial over 16 minus 4 factorial, which is 16 factorial over 12 factorial, 4 factorial, which is C. But like I said, you could type it into your calculator. 16C4, type in all the answers, match the answers, right? 11 says there are 14 players on the Okotoks Fury softball team. Each of the students is capable of playing any fielding position on the team. There are 9 fielding positions, a pitcher, a catcher, 4 infielders, first base, second, third, shortstop, and 3 outfielders, left field, center field, right field. For a particular game, Okotoks Fury is in the field first. If the pitcher must be the oldest player on the team and the catcher must be the youngest on the team, how many different position lineups are possible at the start of the game? So, how could we do this? Are the positions different? Yeah. Is it a permutation or a combination? Yeah.
It's a combination because it says everybody is capable of playing every position.
Everyone is capable of playing every position, which means I don't have to pick like a pitcher from a pitcher. But that doesn't make it a combination.
See, that's what I have.
So it's setting you up. The reason why it's a permutation is you have to look at the things you are picking. Does the order of which you are choosing? So it's the R, not the N. So we're looking at the N and saying all of them can play anything, so that's fine. That's how many you're choosing from. It's the ones you're choosing. Does the order matter? Or are they getting different positions? So the people we're choosing, are they getting different positions? Yeah, they are, right? They're getting shortstop, first base, second base. So the positions, the moment they give you positions to choose them from, it's a perm. I gave this one in this specific spot to challenge people because I knew that it's worded weird. So the reason why they have to say that everyone can play every position, because it's not really true. Not everyone in a baseball team can be a pitcher. We know that. Not everyone can be a catcher, right? And you're not going to pick, oh, the oldest one gets to pitch, unless this is like 9-year-olds. Then maybe that would be the case, right? So I wanted to set you up and throw it in the combination thing to see what you guys would do. But it is, if I give them all different jobs and different positions and we're picking from a big group, then it's a permutation. Now, if I was picking pitchers from pitchers, shortstops from shortstops, third base from third base, second base from second base, it would be a C, correct? If you're picking from the same position, like pitchers from pitchers, that's a C. But the moment I'm giving you a whole bunch of people and I'm picking a pitcher, a catcher, a shortstop, first base, then it's a P, right? C's are when you pick them from the same thing, pitcher from pitcher, shortstop from shortstop, catcher from catcher, that would be a C. So if I had a group of catchers on the team, which you do, normally your team will have like 2 catchers, right? And we're going to choose a catcher from the catchers. 3 pitchers, and we're going to choose the pitcher from the pitchers. Then it would be a C. Does that make more sense? Okay. So this one I would go 1, choose 1 for the pitcher. I choose the oldest. The oldest or the youngest? Yeah. And the catcher, 1, choose 1 for the catcher. And then, or I could do 1 C1 or 1 P1. Does it matter? If you put 1 C1 in your calculator, it's 1. If you put 1 P1 in your calculator, it's 1. It doesn't make a difference because those people are just being chosen once, right? How many are left? 12, and I'm choosing, or picking how many? 7 left, right? What's 12 P7? 1 P1 and 1 P1 is just 1, so that's not going to change anything. B. This one says Sarah is one of a group of 8 people. So Sarah is included in the 8 people, right? She's one of a group of 8 from which a committee of 4 people must be formed. So Sarah is one of a group of 8. So there are 8 people, and I need to form a 4-person committee. The number of different committees possible. Is there anything restricted about this one? No. So what would I have? 8C4. What?
I'm confused with the flow of P7. I know you explained it, but like if they're all utilities, like it's not a C then, because they could all play the same position.
They're still being given a position.
Oh, yes.
They can all play, the group of them can play all the positions,
Mm-hmm.
but they're being chosen to play a position.
Right, because you wouldn't have like 2 shortstops.
Right. They would be like, get out of my spot here. You can get in third base, loser. You go to second, not sitting in my spot. Get out of here. Go left. Back it up. You know, you're in my grill. Yeah, that's what they would say. Yeah.
Okay.
All right. The number of different committees possible if Sarah must sit on the committee. So I have to choose Sarah from Sarah. And then how many are left? Because now I chose Sarah. Yeah, your whistling was getting me to 7. Everyone's going 7. Choose 3, and that's right. 35. Then C says the number of different committees possible if they're filling 4 positions: president, secretary, treasurer, and vice president. Yes, it is. Why is it a P? Why is it a perm?
Different jobs.
There's different jobs. The 4 that I'm picking, it's always this R, right? The 4 that I'm picking are getting 4 different things, so the order matters. So like those 7 that I was picking for baseball got 7 different positions, and that's why it was a P. Oh, didn't put in the numbers. 1,680. All right, here's my standard of excellence. Questions? What the stand? What is that? Standard. I would like to say that the board directed me there, but I was actually just writing that. My brain's halted. It took a break. I don't even know what happened there. It got into like its own problems. Wow. I was trying to put standard of excellence together, but I wrote stand off. Anyways, carrying on. I kind of just broke for a second there, but I'm back. Standard of excellence. Don't you go to do something sometimes and your brain just halts? And it's like you're broken for a few seconds, but then you just give it a little breather. Yeah. Yeah. All right. That's calculus. Is that what you're looking at?
Yeah.
Yeah. It's derivatives. Okay, P. It's pretty. Okay, cool. So when you complain about this, when we start doing these questions and you're like, what is that? Just turn to the back, remember what you could be doing, and then be like, oh, this is fine. I'm good. I'm good here. This is good, because that's
We literally did that last semester.
calculus, derivatives?
Well, yeah.
You did derivatives?
So,
Yay! Okay, carry on. 30-2, much better. All right. So, if I say to you, take a breaker, listen. If I say to you, why are you pointing at me? I'm sure I have it running. That isn't at all what I wanted to press. Haha. Okay. Thank you. Because I do halt and not come back sometimes. So, we're going to the dollar store. You know, like the dollar stores that aren't real dollar stores, they have like all the other options in them, like not dollar items. They're like $1.25 or $3 or $4. They're dollars stores. Anyways, we're going to a dollars store. And I tell you that in order to walk into the store, you need to have at least $3. What does that mean? $3 or more. So if I say at least $3, you need $3 or more, right? If I need a committee with at least 3 people, there would have to be 3 people or more. Correct? Okay, we walk to the dollar store again, and I tell you, in order to buy anything in this store, you need pray for me, at most $4. What do you need? $4 or less. I need some Jesus in my life because I can't speak right now, but you need $4 or less. Cool. All right, so that's all we're doing here. If it says at most or at least, use it with like values. So if I need at most 4, think at most $4. Okay, that's $4 or less. If you think about it with money, people do not get these questions wrong. Okay, so I always may say at most. Thank you. Anyways, we're not even doing that. We're going here. All right, example 1. My brain just keeps like misfiring. It's a bit issue. The student council decides to form a subcommittee of 5 council members. So that's what we need to know. We need to know that in the end, oh, that was not me. That was the board. It's stupid. 5 council members. It's got a flag on it. There we go. Fixed all the problems. Made it have a flag. Okay, we need 5 council members. Then we need to decide, is this a perm or a con? So we need to go search. Are these just 5 council members or do they have jobs? That's really what we're looking for here, okay? So the student council decides to form a subcommittee of 5 council members to look at how funds raised should be spent on the students of the school. There are 11 student council members, 5 sophomores, 6 seniors. Any jobs happening here? No. So we know it's a combination. I'm going to write that to help myself out. And they give you information to help you out. There are 11 of them, and of the 11, 5 are sophomores, 6 are seniors. So if I ask you nothing about sophomores or seniors, you're using the number 11, correct? If I say this many sophomores, this many seniors, we're using the 6 and the 5. We agree? So sometimes you're using the 11 if there's no restrictions. So, whoa, here we are. How many different ways can 5-member subcommittee be chosen if there are no restrictions? 11C5. True that. $462. Now here says exactly 3 seniors. So I know 3 seniors is what I need. And people will tell me, okay, I have to choose that from the seniors. There's not jobs, so 6C3, and they give me that answer, and it will be on the test, and it will be wrong. Why? I still need 2 more people for that committee. This is only a 3-person committee, and I need a 5-person committee, correct? So I need 3 seniors and technically 2 not seniors, which in this case, the 2 not seniors are sophomores. How many of them are there? 5C2. And with an and, what do I do when I use the word and? Yeah, times multiply. $200. Now, here we are to the lesson of today. We need at least 3 sophomores. I need at least $3 because that's where I go with money. Money's easier. If I need at least $3, I need 3 or more or 3 or less. At least $3. 3 or more, correct? Okay, cool. We're going to make cases. When it's at least or at most, you get cases. So we're going to need 3 or more is what you just said. So I need 3 sophomores. Or I could have what? I'm leaving a space for a reason. Or I could have 4 sophomores, so I need 3 or more. Or I could have 5 sophomores. Do I have to stop at 5 sophomores?
Yes.
Yes, for 2 reasons. There are only 5 sophomores. And the most important one, the committee can only have 5 people. Do you see how I have 3 cases? Each of those cases are cases of 5-person subcommittees, correct? However, only the last one actually has 5 people on it currently. What do I need to do to this case? I only have 3 people on it. I need how many?
2 seniors.
2 seniors. Now this one has 4 sophomores, so I need what? And 1 senior. Does this one need any? No. We're good. And the ors mean we add. Or is add. And is multiply. Remember, and add do not go together. So this one's going to be 5C3 and is multiply 6C2 plus 5C4 times 6C1 plus 5C5. Everyone type it into their calculator. You can type it in all at once. You don't even have to do it separately. Anyone get an answer? What'd you get?
Can I have one?
Okay, then we're going to flip over. Okay, we're going to try this one together. It says, consider a standard deck of 52 cards. We have our 52 cards that we always have, orange, suit, everything like that. How many different 5-card hands? This is the key thing. We need to have 5-card hands. In the end, no matter what case we do, it has to have 5 cards in it, 5 cards in it, 5 cards in it, correct? So the first one says no conditions. Are cards perms or coms? They're a combination, so it doesn't matter. The moment you get them in your hand, you can move them all around. You can do what you want with them, except for like war. So if we have 52 C5, that would be no conditions. Now what if I say at least 4 red cards? Let's look at it with money. At least $4. Is that 4 or more or 4 or less? At least $4. 4 or more. Where am I going to stop at? 5 because I need to have 5 cards. So I'm going to have 4 red or 5 red. And each of these cases has to have how many cards in it? 5. The second one already does. Cool. What about the first one? I need 1 something else, right? I need 1 that's not red, correct? It just needs to be not what the heck the other one is. So if I have 4 red, I need and 1 not red. Could I say black in this case because they're opposites in a card deck? Sure. But really you just need anything but red. How many red are there? Half the deck. 26. So we have 26 C4 and means I multiply. And then not reds. 26 C1 or means I add. And then I start over with all my cards again when I get a new case. So 26 red, choose 5. Every new case you start over with all your cards. Next one, at most 2 kings. Let's think about it in money. At most $2. What do I need? $2 or less, right? Think of it in money. Seriously, you won't make a mistake if you do money. You do kings, it's like throws you right off. At most $2 is $2 or less. At most 2 kings is 2 kings or less. So I could do 2 kings or 1 king. And then people often forget this last case. 2 kings or less also includes what? No kings. Or 0 kings. What am I missing? Each case has to have how many cards in it? 5. This one doesn't even have any. Just 0 kings in it. There's no cards. So, this one has 2 kings, and I need 3 not kings. This one has 1 king, and I need 4 not kings. This one has 0 kings, and I need 5 not kings. How many kings do we have to choose from? 4. If we have 4 kings, how many are not kings in the deck of 52? 48, because just 52 minus the 4 off, right? And 4C1 times 48C4. Do I have to go 4C0? Do I have to represent 0 kings? Does that change anything if I pick nothing? No, I just show it so that you can see that case exists. And you could go 4C0, but 4C0 is just 1. And when you multiply something by 1, it doesn't do anything, right? So I don't have to show that. I could just show the 48C5. You try example 3. Or if there's 13 clubs, you take that off of the 52. There's 39 not clubs, right? 52 minus 13 is 39. It's the last one, and then the work is going to be on you. This one's not in that least right most, but it's a unique one, so I'm just going to start just because it's a little bit different, but it is a C one. And it's where I give you a total, so it's kind of like a little bit of an extension one. So here it says, during a Pee Wee hockey tryout, all the players met on the ice after the last practice and shook hands with each other. How many hands come together when you shake hands? 2. So I know I'm going to choose 2 at a time. And I know it's a C because it doesn't matter if someone comes in aggressively with a handshake and meets the other one before the other one, whatever it is. The order doesn't matter, right? The 2 hands, until they hit each other, don't make a handshake. Doesn't matter if this one comes in really fast and this one comes in slow. Order doesn't matter. 2 hands, handshake, right? So it's a C. Now, here it says there were a total of 3 handshakes. I gave the answer, right? I gave what the answer would be when we're done. There's a total of 300 handshakes. So that's going to be equal to. Determine the number of players on the ice. What am I making you find? N, right? What do we know about N? It needs to be greater than or equal to R. So I could go 2C2, 3C2, 4C2, 5C2, 6C2, 7C2, right? Figure it out. See what gets you 300. What do we get for N? 25? That is 2. Oh my gosh, why is it not wanting to write this here? And then you would have a sentence, you'd say the number of players on the, there must be 25 players on the ice, right? Okay. Number 1. Number 2. Number 3. And number 4. Okay, 1, 2, 3, and 4.